if you go for a lunch or dinner to your friend and he serves you basically simple roti, dal, rice and sabji, then how do you feel? You feel that it's not good and you will curse your friend that what kind of food he has served to you, which can neither fill up your stomach nor your heart also, and you will not be that satisfied. But in other case, if you go to a friend who serves instead of roti, paratha, instead of dal, it's tadke wali dal, and then it's a fried dal basically, and instead of plain rice, he serves you pulao, and vegetable also is plain vegetable or plain sabji. Against that, he serves you a very good masaledar and very tasty sabji also. So what will you do? You will praise the friend and you will say also that it's very good and I am very happy and my stomach is full, but I am not satisfied inside because this preparation is so good. So, why this has happened? This has happened because when your friend, the next friend has added, instead of roti, he has added paratha which contains your ghee and all, onion also. Then in dal, it's not plain dal, it's a fried dal which again contains ghee and sometimes hing, then onion, lasan and all those things. And instead of plain rice, he has served you pulao. Again, it's a combination of different spices as well as some green vegetables cut into small pieces and then fried again. So you get a good pulao. And again, the sabji is very delicious sabji, whether it is a matar paneer or palak paneer, and you enjoy this food. So these changes has come because of these additions. And these additions may vary from one preparation to other preparation, maybe in a combination or in a single use. So similar thing has happened in case of steel also, where steel contains basically iron as the main element, and then carbon, manganese, silicon, phosphorus and sulfur. These are the essential 5 parts of any steel. But when you add chromium, nickel, moly, vanadium, cobalt, tungsten, all these elements, then it increases the quality of the steel, properties of steel, mainly the hardness, tensile strength, impact resistance, ductility, heat resistance, corrosion resistance, so many things. So you get a good quality of the steel as per the use. And this also again, in this case, you are adding only either a single element or a combination of elements. So these elements are basically known as alloying elements in steel, and these elements are basically affecting all these properties. So today I am going in part 7 on this effect of alloying elements on steel properties. I am going to tell you about all this, that what happens when these alloying elements are added in a steel and how they increase the property of steel. So I hope you will like this and it will be very useful to you for your future application. Hello friends, welcome on part 7 of heat treatment of steel on my channel Jagdish Chaubey. As I told in the intro to this video, that this particular part 7 is on effect of alloying elements on steel properties. So let's see what it contains. Content is, first of all, flashback. See, prior to this video I have already made 6 videos on heat treatment. 1 to 5 was in one batch, and this is the second series, which is 6, 7 and 8 I will be covering. So in first series, part 1 to part 5, it was basically on basic heat treatment thing, what is heat treatment, why it is required, what is the advantages of heat treatment, then various heat treatment processes like normalizing, annealing, hardening and tempering, and very important diagrams like iron carbide diagrams, TTT curves, CCT curves, microstructure, and all those things were discussed in the part 1 to part 5. If you have not seen this part 1 to part 5, I request you to kindly go through it, because all these things are all interconnected. So you have to go through again part 1 to part 5 you have not seen. Now the part 6 was basically on hardenability, factors affecting hardenability, and the last was in application. Now this part 7 is on types of alloying elements in steel, effects of alloying elements on steel properties, and there are advantages and disadvantages of alloy steel. So what is alloying element? Alloying elements are those which are added in plain carbon steel to improve various properties of steel, such as mechanical, thermal, and chemical properties. This I can describe. Mechanical properties like hardness, tensile, impact, ductility, all these things are mechanical properties. Then thermal properties, it comes heat resistance of that steel is known as thermal properties. And in chemical properties, basically it is corrosion resistance. So all these things are affected when you add alloying elements. And what are those alloying elements? These are like chromium, nickel, moly, vannic, cobalt, tungsten. All these things they are all alloying elements which are added in steel, and this steel is known as alloy steel. Now alloy steel has got two types. One is low alloy steel, and which contains less than 10%, and the other one is high alloy steel, which contains more than 10%. Means total alloy content is less than 10%, it is low alloy steel. Total alloy content is more than 10%, then it is known as high alloy steel. Okay. Now I have shown you this table. I will read this table, serial number, then the alloying elements, then effect on ferrite, effect on hardenability, carbide forming tendency, then action during tempering, and principal functions. So I will read for one only. Like chromium, when you add chromium, this, as far as ferrite is concerned, what is the effect? It hardens slightly ferrite, and it increases the corrosion resistance. This is a corrosion resistance when you add chromium in the steel. On hardenability part, this increases hardenability similar to manganese. On carbide forming tendency, this greater than manganese, but it is less than tungsten, the carbide forming tendency. Okay. Then we go for action during tempering, means when you temper it, what is the effect? So it says mildly resist alloying softening, means when you temper it, the softening is very light, means the drop in hardness value will be not much, it's very light. So this is the effect of tempering. And if you go for this principal functions, then this is basically increased corrosion resistance, it increases corrosion resistance and oxidation resistance also. Then it increases hardenability, increases strength at high temperature. It increases strength at high temperature. So these are one thing which I have told about chromium also. Similarly, there are other effects like cobalt, manganese and other alloying elements, and they have got different effects. This table is quite large table, so I am not going to discuss in full because then it will take too much time. You can go through it. This table I have given for you people just for information purpose. If you want to refer it, you can refer it. Okay. So the same table is there. I am going ahead of this. And the last one is molybdenum. So I pass it on. Now I come to effect of alloying elements on heat treatment. What is the effect of alloying element on heat treatment? It says first, improvement of strength at elevated temperature. Yes, if you go on the higher temperature also, the strength of the steel increases, that there is an improvement. Then increase of depth of hardening so that the large sections can be treated. It means that when you harden it, the depth of hardening is higher because of alloy addition. The example is, if you take a 60 dia steel rod and you take one mild steel, one alloy steel, and you quench under same condition, then you will see the depth of hardening in case of mild steel it will be very low and very less, whereas in case of alloy steel, the depth of hardening will be much more than your mild steel. So this increases depth of hardening even if it is a higher section. Then refinement of grain and high toughness. Grain refinement is also there. It refines the grain, means basically it gives fine grain size and high toughness. If the grain size is fine, then toughness is definitely high. Then the improvement of magnetic particle alloying addition, they improve also magnetic and non-magnetic areas, and increase in abrasion and wear resistance. This also is part of, because of heat treatment cycle you select, it increases abrasion and wear resistance. Now, effect of alloying elements on steel properties. Now I go, see, this is in center, effect of alloying elements, and these are the most common alloying elements which are used in steel. Like I go for first chromium, I have already discussed earlier also. It increases hardness, strength and wear resistance. Then nickel, it increases hardness, strength, wear resistance, fatigue strength and shock resistance. Fatigue is in case of dynamic condition where there is a movement like to and fro motion, like you take the case of springs, okay, it just vibrates, and then rotating motion. These are parts of the dynamic motion, and in this case the fatigue strength is much more because of this nickel, this added. And the shock resistance, when there is any shock, it resists the shock basically. So wherever there is a application where it requires a great shock resistance, you have to go for this nickel steel. Then moly, it increases great toughness, high hardenability and fatigue resistance. These things are improved when you add moly. Then tungsten, this increases your hardenability, strength, abrasion and wear resistance. Abrasion and wear resistance, almost similar thing when the two parts are rubbing against each other or it's moving on each other, then this abrasion and wear takes place. So when you add this tungsten, it increases the abrasion and wear resistance. Then vanadium, it increases strength and fatigue strength. That is there, fatigue resistance or strength is increased. When you say strength, it means it is on good side. When you say resistance, it is on the negative side. So it takes care of fatigue basically when you add vanadium. Then you see cobalt is there. This increases its strength and hardness. Also increases then hardness at high, it increases strength and hardness. That increases red hardness in high speed steel. What is this red hardness? Red hardness is basically that hardness wherein you heat that steel to a very high temperature, but still it retains its hardness and strength. Particularly it is required for high speed steel where you go for a very high temperature application, but you want to retain the hardness or strength of that steel part which you are using. So for this you have to use cobalt also. Now manganese, extraordinarily toughness and abrasion resistance, particularly in case of 12 to 14% manganese and 1.1 to 1.3% carbon steel. In this case also you see the toughness is extraordinarily increases. Okay, and along with this abrasion resistance. But this is in case of a particular composition which is given here. Okay, so this particular steel is also known as head-filled steel, and basically in railway tracks where this wheel runs over at a very high speed and there is a very high abrasion and wear resistance also, and there is requirement of toughness also. It basically absorbs the shocks which is imparted by the wheels when they are running on the track. So this also is very important, manganese, and this head-filled steel generally used in railway tracks. So these are some of the application and increases in the properties when you add this chromium, nickel, moly, tungsten, vanadium, cobalt, manganese, and there are others also, but I am generally considering on the main alignment which are required. Now effect of alloying element and steel properties. See, iron with chromium, it increases high hardness, high strength. Okay. It increases hardness and then iron nickel toughness. See, this toughness has come wrongly here. This toughness should come here after this. Okay. So it is high hardness, tensile strength and toughness. So these things are improves. Then if it is iron, nickel and chromium, these are now two elements are added. This increases higher tensile strength, then it's good wearing and shock resistance. Okay. And also fatigue resistance, steel. So this is the effect on the steel properties when this nickel and chromium both are present. Now when this moly is present, then it gives, it's not moly, it's manganese. Then it gives extraordinary toughness and high abrasion resistance. This is also part of that application of this manganese as a alloy element on steel properties. Then I go for iron along with the tungsten. What it says, high hardenability steel when used along with chromium and vanadium. Means when this tungsten is used along with chromium and vanadium, it gives very good high hardenability and can be used in tool steel and high speed steel. That is why this combination, tungsten, chromium, vanadium in combination can be used for tool steel and high speed steel, where you want a very good high hardness, and even red hardness is also required here. For iron and molybdenum, it is greater ductility and toughness is there. Then it gives greater hardenability in presence of chromium, greater machinability at high hardness. It improves creep resistance at high temperature. What is this creep resistance? Creep resistance is nothing but resistance of the material to failure at very high temperature. When somebody is working on a very high temperature, continuous application, and the material resists any cracking or any damage, then we say that creep resistance of that material is very high. This particular phenomenon is used for high temperature applications such as aeroplane, where this engine of the aeroplane, where this temperature is quite high, and there are some of the parts which are used for this engine parts, and they are all creep resistance part. Okay. Then we come to iron and vanadium. This improves fatigue resistance and again creep resistance. So these are the various alloying elements and their properties on steel. Now I'll go for advantage and disadvantage. So advantage is, I'll just read it, greater hardenability, less distortion and cracking. Because of this, the distortion and cracking is quite reduced. Greater stress relief at given hardness. At particular hardness, the stress relief is good, means temperature and hardness can come down. It's very, very good. So stress relieving is good. Then less grain growth. This restrict grain growth also. High fatigue resistance. Advantage is there. Great high temperature strength. This Avril also explained high temperature strength. Okay. Then better machinability at high hardness. That is also one of the advantages of using this alloy steel, that you get a good machinability at high hardness also, and better ductility and high strength. Means all these mechanical properties, chemical properties, and earlier what I told you, chemical, mechanical, and then thermal properties. They basically improve when you add this. So these are the advantages. And when we see disadvantage, these steels are quite costly because all these alloying elements, nickel, chrome, moly, vanadium, they are very costly. So this increases the cost. It needs basically special handling. When you heat treat this material, you have to take special precaution during transfer of material from one plant to other plant, even from one furnace to other furnace, and the type of cooling there also you need to have a greater control on cooling rates. So these are the actually disadvantages. And the temper brittleness in certain grades. In certain grades there is a temper brittleness. What is this temper brittleness? Means at high temperature when you temper it, the steel behaves slightly brittle. So that's why we call it is a temper brittleness. So these are the various disadvantages. Okay. So one thing more I will tell about heat treaters. What is the advantage of this particular slide is, based on the application, if you know the application, where it is you can decide about yourself that what steel I should ask. Okay, this you can decide very well. And similarly, the other way also, that if some steel is given, you can decide based on the steel content and this alloy content, you can decide upon the heat treatment cycle. Then you can decide about the cooling rates also, so that you get the desired property. So this is the advantage of knowing this about alloying elements which are in the alloy steel, and how you are going to treat them during heat treatment. Okay, and what precautions also you have to take. Like I told you, just precaution, special handling process is also required. So these things are very useful for a heat treater. Okay, so I think I have covered most of the things, and I hope that you will take advantage of this particular slide. Maybe there were some slip of tongues which I think you can ignore it. It generally happens. Okay, nothing to worry about it. Okay, so with this I am finishing this part. Next part will be on quenching. This is again a very important part on heat treatment, particularly for heat treaters. What is this quenching? What are the different type of quenchant used? What is the quench severity? So many things are there in quenching, and it effects occur. Tempering another thing when you quench anything. Okay, so please go through that also. Wait for that particular part, and you see this part to full length. Share it to your friends, and if you like, then also comment. Give your comment, give your suggestion. If you want to cover me something else apart from this, you can also suggest this, so that I take care in my next videos on heat treatment. So thanks for your patience listening. Thank you very much.